bromamide reaction. Hoffman bromamide. Hoffman bromamide reaction. This is also called as Hoffman bromamide degradation reaction. Degradation. Degradation reaction. Hoffman bromamide reaction or Hoffman bromamide degradation reaction. First condition. See, our aim is to prepare amine from amide. See the condition, amide should be primary. Amide should be primary amide. Amide should be primary. Okay. Next, only primary amines can be prepared. Starting reactant should be primary amide. We'll get primary amine. Clear? In Hoffman bromamide reaction, we can prepare primary amines, including both aliphatic and aromatic also. Clear? Mention that. Primary amines only. Primary amines only can be prepared. Primary amines only can be prepared. Okay, within the bracket both aliphatic and aromatic. Both aliphatic and aromatic. There is no specification. Both type of amines can be produced, aliphatic as well as aromatic. Right? Online students, shall I clear this? Okay, all of you. Right. Let us see the reaction and the reagent. R C double bond O NH2 gives rise to RNH2. Reagent is NaOH plus Br2. NaOH plus Br2. Or you can use NaOBr. Both are same. NaOH plus Br2 or NaOBr, because when we mix these two, we will get this one. Right? You can use KOH also, KOH plus Br2. Another combination, KOH plus Br2. Right? And observe the points. I mentioned one word, degradation reaction. Degradation. In this, if n number of carbons are present in the reactant side, here you will get a n minus 1 carbon, that is degradation. Decrease in the number of carbon atoms. In which of the following reaction number of carbons will decrease? Degradation. If 4 carbons are present in the reactant, you will get 3 carbons only. Degradation. Clear? Okay. Right. It is the shortcut mechanism to write the product. How to write the product? We are taking amide and we are writing amine. How to write the product with shortcut? See. Yes, trick. Cut C double bond O and attach NH2 to R group. Cut carbonyl group C double bond O and attach NH2 amino group to R. See this? R C double bond O NH2. Look at this, all of you. See, cut this, break that. cut C double bond O, attach nitrogen or NH2 to R. Remove this and attach NH2. Very simple. R may be anything, aliphatic, aromatic, anything. How to write the product? Remove C double bond O, attach NH2. Clear? So, RNH. I'll give the byproducts later. First of all, let us understand the simple mechanism, shortcut trick. Then we will go with the mechanism and exceptional cases, right? Very simple trick to write the product. Cut C double bond O, attach NH2 to R. First of all, let us write products based on the shortcut mechanism. After that, we will go with the mechanism. Number of moles of NaOH used, bromine used. Okay, original mechanism, balanced equation. Okay. Write examples. What is the mechanism? Trick. Remove C double bond O, attach NH2. Right? Condition amide should be primary. You tell me how to identify primary amide. You know primary amine. In primary amine, NH2 is present or NH is present or N is present? NH2. In primary amine, which is present? NH. In primary amide, NH2 only present. R C double bond O NH2. Same. Primary amine, primary amide. Both are same. CONH2. Primary amide. If I take secondary amide, then reaction do not take place. Right? See the examples, and names also important. Few amides and their names. First example, what is its name? What is its name? Its name, amide's name. Ethanamide, alkanamide. Alkanamide is the suffix, alkanamide. Ethanamide, methanamide, propanamide, like that. How many carbons are present here? 2 carbons are present, right? So, amide, ethanamide, commonly called as acetamide. How many carbons are present? 2 carbons are present. So, ethanamide, also called as acetamide. That's why nomenclature is important. Everyone should thorough in the nomenclature of first year. Okay, right. What is the reagent? NaOH plus Br2. NaOH plus Br2. Right. How to write the product? C double bond O. Cut C double bond O. Remove this. Cut this and attach NH2 group to methyl. So methanamine or methylamine. Common name is methylamine. Okay, right. Second example, what is its name? Benzenamide. Same, NaOH plus Br2. Name of the amine is aniline, aromatic. We can prepare both aliphatic amine as well as aromatic amine. In Hoffman bromamide reaction, can we prepare aniline? Yes. Aromatic amine can be produced. Same mechanism, shortcut mechanism. Cut C double bond O, attach N. See here. Cut this, attach nitrogen here, NH2. Okay. Secondary amide. Okay, you want secondary amide. I'll give the reaction. Okay, as a third example, CH3 C double bond O NH CH3 NaOH plus Br2. Put into mark. No reaction because it is a secondary amide. N-methyl ethanamide. Do not undergo Hoffman bromamide reaction. What is its name? Yesterday I given nomenclature of secondary amines, right? First we have to write the substituent Clear? N-methyl butanamine, propanamine, like that. Clear? N-methyl ethanamide, 2 carbons, 1, 2. Do not undergo Hoffman bromamide reaction. N-methyl ethanamide, no reaction. Similarly, tertiary also. Tertiary means in place of hydrogen we take another. N comma N dimethyl. Tertiary amide also do not undergo. For J means level, mechanism is needed. Original mechanism. For need level, no need. And I will give you one important point. After learning mechanism, you will learn one point. I will give you that point direct. Because this is lengthy. Original mechanism. Right? Okay, this is general reaction. Now coming to the conversions. Conversions are very, very important. You know, direct reactions, probability is less. Conversions. Now you tell me how to get amide. You know already. How to get amide. In which chapter we prepared amides? Yes, carboxylic acids. In carboxylic acids we prepared amides or not? How? Yes. Next one, conversion. Shall I clear this? Other students, all of you. Okay. Conversion type question. See, A to B, B to C, C to D, D to E, E to F, and so on up to Z also. But now we learn only few conversions. Right. Easy conversion or tough conversion? Easy or tough? Medium. Little bit tough. Tough. H3O plus. Say the product, old students. Cyanide upon hydrolysis, what we will get? In the place of cyanide, COOH will come. CH3COOH. When we add water, entire cyanide will convert to COOH. Clear? Right. Next, ammonia. In the last chapter we did under properties of carboxylic acids. What is the product? Yes, CH3COO, NH4. Ammonium salt of carboxylate. Like sodium salt of carboxylic acid, CH3COONA. CH3COOK means potassium salt of carboxylic acid. Ammonium salt of carboxylic acid. Clear? This is also last chapter concept. Last chapter chemical property. Carboxylic acid chemical property. Right? Okay. Next, this is unstable. Unstable. Upon simple heating, it loses water molecule. Simple heating. Remove water from this. 2 hydrogens, 1 oxygen. So what we will get? Yes. CH3 C double bond O NH2 amide only. You can write like this also. CH3 CO H2, both are same. See, by the elimination of water, loss of water, we will get amide. Now Hoffman bromamide reaction. Use the reagent of Hoffman bromamide. What is Hoffman bromamide? NaOH plus Br2. You never get a direct reaction, you will get conversions only. Most of the, in weekend also you can see. Already you are writing tests, right? Shortcut mechanism. Cut C double bond O, attach NH2. Cut this and attach NH2. So methylamine or methanamine. Conversions. See. Cyanide to acid, acid to ammonium salt of carboxylic acid to amide to amine. Indirect question. Okay. Akshara will tell us how to get cyanide. Yeah, how to get cyanide. From which compound you will get cyanide? Cyanide I am asking. How to get cyanide? No. Cyanide from this. KCN or Yes. First chapter. So we can write number of steps from amide. Yeah. But we are preparing amide only. Let's see this. NaOH plus Br. See, two reactions we are merging. You know haloform reaction. Huffman bromamide. This part is Huffman bromamide. This part is haloform. So within single molecule we are writing two different reactions. We are covering two different reactions. Clear? You know how to write the product in the haloform. How to write the product in the haloform? Remove. Don't write C, all of you. You know Huffman bromamide. Cut C double bond O. Attach NH2. First. Remove this CH2, CH2, NH2, NH2. Okay. Next, this is haloform. Once I will remove haloform reaction. C double bond O, CH3, NaOH plus Br2 or Cl2 or I2, you know. This part will convert it to carboxylic acid. Carboxylic acid. This part will convert it to haloform, CH3, CHCl3, CHBr3. Clear? If you give gap, slowly you will forget. So keep on revising. And one more point I am telling you. After completion of organic chemistry, I will keep organic DPPs. Okay, daily you are coming to half-line. Daily you have to write 5 reactions until your IP exam. That is mandatory. If you come to half-line, you can take one DPP. So that will cover all the reactions from alkyl halides to amines. Right? For online students also I will send that. Clear? Up to your IP exam. Irrespective of your practical exams, your IB exams will be conducted in the middle. Your unit tests, okay, irrespective of your work, you have to do daily 5 questions. After completing amines, I am planning for that because you will forget. If you don't do like that, again you have to read organic freshly. Everything will be fresh. Here we will plan that later. Okay. Sorry. And this part will convert it to RCOOH. This part. Write R as it is. I said same. Write R as it is and attach COOH. Write R as it is and attach COOH. And this part will convert it to chloroform. CHCl3, CHBr3. Based on the given halogen. Clear? Okay? Right. Now this is R part. So this benzene ring is the R part. Okay? COOH. Can we write COOH like this? C double bond OH. This is R. So R is written as it is. To R you have to attach COOH. And this will be eliminated as CHCl. CH. Right? This is final product? No, this is not final product. Here one electrophile site is there. Electrophile site. This carbon is highly electropositive because this carbon is attached to oxygen and oxygen. 2 more electronegative atoms are there. Okay. And you know nitrogen contains one lone pair or not? Nitrogen contains one lone pair. This lone pair attacks. carbonyl carbon, because that is highly electropositive, because that is connected to two oxygen atoms. So more positive is present. So this lone pair easily attacks this. Right? But around carbon, how many bonds should be present? 4 bonds only. Already this carbon is surrounded by how many bonds? 1, 2, 3, 4. And one new bond is forming or not? But 5 bonds are not possible. So when lone pair, nitrogen with the help of lone pair forms new bond, this OH group will leave. OH minus. Okay? Because 5 bonds are not possible. One new bond is forming here. So this will leave. OH leaves along with the bond pair of electrons. Clear? Remaining product is CH2 NH2. Can I write NH2 like this? HH NH. Next, C double bond O, one new link is forming, right? And nitrogen is giving its pair of electrons, so nitrogen gets which charge? Positive charge. Positive. And here minus OH minus you can write. Minus OH. Means OH minus is eliminating. OH minus is eliminating. Clear? Why nitrogen is getting positive charge? Because nitrogen is giving its pair of electrons. Okay? But nitrogen with positive charge is unstable. So this hydrogen leaves. One hydrogen will leaves by losing bonded electrons here only, or giving bonded electrons to nitrogen. Minus H plus. OH minus H plus. H2O. H2. Here we will get a CH2 NH C2. I wrote in the bond line representation. Okay. This is very important model question. Halfman bromamide extension. You are not learning simple Halfman bromamide. You are just mixing with other reactions. Okay. Now copy. Did you get Aishwarya, Ayesha? All of you, Kritika, Mazia, every girl, Adiba, everyone. Are you there, Adiba? Very, very important reaction this is. Note down. Now coming to the original stoichiometric equation. We did generally shortcut mechanisms only will come. Questions will come like this only. You will get the reaction, identify the correct product. But sometimes we will get questions on the stoichiometry also. Right. Note balanced equation RCONH2. Tell me, what are the reagents? What I used? Br2 NaOH. Don't write sequence. You know product R NH2 plus 2 NaBr plus NO2CO3 plus water. This is very, very important. Stoichiometry of bromine and NaOH. 1:4. Very, very important. Stoichiometric ratio. How many moles of NaOH is used to produce 1 mole of amine? What is the answer? How many moles of NaOH is used to produce 1 mole of amine? What is the answer? 4. How many moles of bromine is used to produce 1 mole? 1. Okay, remember the ratio. You can write like this. Br2 is to NaOH is to amine is equal to, tell me, 1 is to 4 is to 1. By using a powerful reducing agent, lithium aluminum hydride. RC double bond OH2 lithium aluminum hydride, also represented as LaH, lithium aluminum hydride. CH2H2. The role of this reagent, C double bond O will convert it to CH2. In place of C double bond O, write CH2. Okay. What is the meaning of reduction? Removal of oxygen and addition of hydrogen. Oxygen is connected to carbon through double bond, right? So when we remove oxygen, okay, 2 bonds are vacant, right? So we have to add 2 hydrogens there. 2 bonds are present or not? Like this. If you remove oxygen, 2 bonds are vacant. So you have to add 2 hydrogens. Remove 1 oxygen, add 2 hydrogens. Right? Or you can follow this shortcut mechanism. This one. Remove C double bond O. In place of C double bond O, write CH2. One example. CH3, C double bond O, lithium aluminum hydride or LaH. In place of C double bond O, remove total C double bond O and put a CH2. A very important point, which amine we are preparing by this method. Primary ammonia, that very important. That point is very important. You will get question like this: in which of the following secondary amine is produced? That is also one question. Clear? In the Hoffman bromamide we prepared primary amine. By using lithium aluminum hydride we produced primary amine. Mention that only primary amines can be produced. Only primary amines can be produced. Next method, Hoffman bromamide reaction is our next named reaction, Gabriel phthalimide synthesis. Shall I clear this? Online students, shall I clear this? Yes. Primary only, that is. Gabriel phthalimide synthesis. Gabriel thalamide synthesis. Gabriel thalamide synthesis. Here also important point. Only primary amines can be produced. First preparation method primary, second preparation method primary, third preparation method primary. Okay, and one additional important point, only aliphatic amine can be prepared. In Hoffman bromamide, aliphatic primary, aromatic primary, but here only aliphatic primary. Aromatic primary amine means aniline cannot be produced. Aniline cannot be produced. Why aniline comes under aromatic primary? Aniline cannot be produced by this method. Aniline cannot be produced. Aniline means primary aromatic amine. Primary aromatic amine cannot be produced. Okay. In Gabriel thalamide synthesis, aryl halides do not participate. Actually, we take aryl halide to produce amine. Not aryl halides or alkyl halide we take. In place of R, we should not take benzene ring. Very important point. Aryl halides do not participate in Gabriel thalamide. We know the reason also. Mention that point. First, I am giving important points. Clear? Aryl halides. Aryl halide and tertiary alkyl halide. Aryl halide and tertiary alkyl halide do not participate in Gabriel thalamide synthesis. Do not participate in this synthesis. Let us start. What is Gabriel thalamide? What is reagent, reactant, product? Mechanism. Mechanism is which part? Mechanism also very easy. Here, let us start. Thalamide. You know thalic acid? What is thalic acid? Benzene with two COOH groups present in adjacent positions is called as thalic acid. Thalic acid. I'll give you preparation method also later. First, I'll give you basic equation, right? I'm taking thalamide, Gabriel thalamide, This is thalamide. See, two reagents, NaOH, sodium hydroxide, second one, amine, primary and secondary also preferable, tertiary do not. I mentioned already aryl amine. What I wrote, aryl halide, aryl halide I wrote. Just a second. Cl, okay. Alkyl halide, not amine, sorry. And third one, hydrolysis. Hydrolysis is common. Okay. Let's see that very simple trick. You no need to do any big mechanisms, right? No need to practice any lengthy mechanisms. Here we are taking alkyl halide, right? But condition that alkyl halide should not tertiary, that should not aryl halide. That is very important, right? Take this R as it is here. Take this R as it is. Take R as it is. Attach NH2. Or simply write R, attach NH2. In place of R, like methyl, methylamine, ethylamine, you can take cyclohexyl group also. So what you have to do? Take that R, attach NH2. In alkyl halide, R is present or not? Write that R here and attach NH2. You are preparing amine, so attach NH2. Clear? What is the trick? Tell me. Take out R. R from what? Which? R from alkyl halide and attach NH2. Okay, shortcut trick. You can say the product easily now. You know how to write the product in the easiest way. I am giving one example to you. Look at this. C double bond O, C double bond O, NH, NH. What is first reagent? Sodium hydroxide. I am taking ethyl chloride, followed by hydrolysis. Tell me what is the trick? What is the trick, online students? Tell me, online students. Say the product, online students. What is the trick? What is the name? What is R here? Write R. Next, attach NH2. Take R, attach NH2. Over. Primary amine. Did you get online, students? How to write the product in the Gabriel thiamine? All of you. Okay. Write R as it is, attach NH2. But you have to remember the reagents. NaOH, alkyl halide, water. NaOH, alkyl halide, water. And one more hint, thiamine, Gabriel thiamine. This is thiamine only, Gabriel thiamine. Trick, take out R from the alkyl halide and attach NH2. Which alkyl halide I should not take? Tertiary and aryl halide. I mentioned already. Aryl halide and tertiary. Why? Let us see. Right, mechanism. Mechanism is very easy. You can copy the mechanism. Mechanism will help you to remember the reaction or to write the product easily. Start the mechanism. Sorry. Yes. That's why name is Gabriel thiamine. We can take substituents, some methyl something, but plain is preferred. This part is important, thiamide part. I mentioned already. Aryl halide, tertiary alkyl halide do not participate. Right mechanism. First listen. I will give the time for the copy. What is first reagent? Sodium hydroxide. OH minus is a base, good base. This OH minus capture acidic hydrogen. What is acidic hydrogen? Hydrogen which is present on the more electronegative atom. Acidic. This is acidic hydrogen. This is present on more electronegative nitrogen atom. So this hydrogen leaves without a bond pair, without any bond pair, like this. Or this OH minus capture hydrogen without a bonded electrons. That bonded electrons shifts to nitrogen like this. Here one bond is there between N and H. That bonded electron shifts towards nitrogen, shifts onto nitrogen atom. Clear? Nitrogen hydrogen bond is there. Nitrogen hydrogen. Hydrogen leaves without a bonded electron. This bonded electron shifts towards nitrogen. Right? Nitrogen with a negative charge. Okay. OH minus and H plus both are eliminated as water. This is step 1. Any doubt in the step 1? Online students. Online students. Girls, what about you? Step 1 is over. Next, step 2. Take this as it is. What is SN1, SN2? SN1 takes place in how many steps? 2 steps. Step 1 is formation of carbocation. Step 2 is attack of nucleotide. What is SN2? Any idea? SN2 takes place in 3 steps. One step. Backside attack or front side attack? SN2 is a backside attack. What we took here? Alkyl halide. Let us take that reagent directly. I took ethyl chloride. That is good one. You can take RX or you can take direct example. CH3, CH2, Cl. Okay. This step is important. Nitrogen with a negative charge. This carbon is connected to more electronegative chlorine. Halogens are electronegative only, no? So this carbon gets which charge? Positive charge. This gets positive and this is negative. SN2 mechanism. SN2 very important. In SN2 mechanism, which alkyl halide readily participate? Primary. SN2. That's why tertiary alkyl halide is not preferred. You wrote at the beginning because mechanism is SN2, backside attack. Right. Then Cl will leave like this. Right. This total ring attaches to carbon. At that time, Cl leaves. In SN2 path. Okay. Now you tell me where new link is forming. In between which 2 atoms new link is forming? Tell me. Between carbon and nitrogen. New link is forming or not? Between N and carbon. New link. Right. Next. Hydrolysis. I mentioned hydrolysis. in the main reaction, H3O plus. Okay. Addition of water. What is the formula of water? H2O. Break this bond. H2O. Or can I write HOH? Water dissociates into H plus and HOH. Okay. Next. HOH. Now what about this part? This total part is CH3, CH2 and H2. Byproduct is, say byproduct name. What is byproduct? COOH, phthalic acid. Primary amine. Phthalic acid and ethylamine, primary amine. So this is about the mechanism of Gabriel phthalimide synthesis. Preparation of amines from nitro compounds. Metal plus acid combination. You can continue. I will send the videos for the two preparation methods. We completed two preparation methods. Okay, you can watch the two preparation methods, Meenakshi and Bhakti. If you have any doubt, I will explain. Okay, you can continue from nitro compounds onwards. Preparations of amines. You can leave two complete papers. Bhakti and Meenakshi. Yes. First three are very easy. Metal plus acid, metal plus acid, metal plus. Sorry. After completing amines. Total biomolecules we have this week, entire biomolecules are only carbohydrates. Carbohydrates, disaccharides only, no need to worry, one class is enough for them. Okay. Total biomolecules means it is very difficult. Carbohydrates, amino acids, vitamins, hormones, proteins. See, from nitro compounds. Metal plus acid common. Iron, tin, zinc. These are the metal plus acid. And H2, nickel, palladium. Catalytic hydrogenation. Reduction methods. All these are reduction methods. You can write here reduction methods. Reduction method. Removal of oxygen and addition of hydrogen or NH2. Okay. Mention here also primary amine only. Primary, all are primary amine. That's why preparation of secondary amine is important. Primary amine is common, so preparation of secondary amine is important. These are concerted type mechanisms, concerted type reactions, no mechanisms. You have to remember to convert NO2 to NH2. Okay, direct reactions. Example, what is its name? आपको बहुत प्रणाम है सभी लोगों को. Very simple compound. This is one student said answer online. Nitromethane. Any reagent, 13 plus HCl. In place of NO2, we write an H2. But you know what I am going to say? But you know, direct reactions never come. Conversions. Yes, super. Conversion type. One conversion type. Have you completed this up to this? Online students, over up to this. Okay. I'll use fresh page. What is Markovnikov's rule? What is Markovnikov's rule? Negative part adds to carbon with a less number of hydrogens. HBr, H2O2. Anti-Markovnikov's rule. Markovnikov's rule. Here we will get a CH3, CHBr, CH3. Negative part adds to carbon with less number of hydrogens. Here anti-Markovnikov's negative part adds to carbon with more number of hydrogens. Alkyl halides preparations, these are first chapter. When I use AgNO2, you know NaNO2, KNO2, one set, AgNO2, other set. With NaNO2, KNO2, what we will get? Rx plus NaNO2, Rx, alkyl RONO, alkyl nitro. Once see all of you, Rx NaNO2, Rx AgNO2, alkyl halide chemical property, RONO, RNO2. Got it? Revision. Yes, tell me. Yeah. I didn't say no to you. You can continue. In place of halogen, keep NO2. CH3, CHNO2, CH3. Here CH3, CH2, CH2, NO2. Nitroalkane preparation, this is nitroalkane. Now coming to the amines preparation. How to convert NO2 to NH2? By using reducing agent like ZnHCl, SnHCl, FeHCl, H2 nickel. Right. SnHCl is commonly used, so I am using that. Sn plus HCl. In place of NO2, what we write? NH2. Here CH3, CH2, CH2, NH2. What is the relationship between these two? Which type of isomers these two are? Positional. One propanamine, two propanamine. Positional isomers. These are conversion type questions. Clear? NO2 will convert it to NH2 by SnHCl, tin, Sn is tin, ZnHCl, FeHCl, and H2 nickel, H2 palladium. You can add one important reagent, actually I forgot to give. This is only actually main. You know about that powerful reagent? LiLH. Actually that we have to write that only first. LiLH. You can add write like this, okay. Please add that is very important. Lithium aluminum hydride. Add left hand side. Or you can add here also. Lithium aluminum hydride. Okay. Online students, shall we go to next example? Next example. No one is responding. Hello, are you there, online students? SnHCl. Or we can use FeHCl. LiLH for this is very important point. We cannot use lithium aluminum hydride for NO2 because we will get a different reduction product. Because this is a powerful reducing agent, we will get azo compounds instead of getting aniline. So very important point, to reduce nitrobenzene to aniline, we do not use lithium aluminum hydride. For aliphatic you can use, for aliphatic we can use, but for aromatic nitro compounds you cannot use lithium aluminum hydride because it will give azo compound. It is a strong reducing agent, complete reduction takes place, okay, to get azo compound. So very important point. Clear? Nitrobenzene to aniline. Clear, all of you? Best reagent. Yes, for aliphatic you can use. Don't use when you take nitrobenzene. Don't use lithium aluminum hydride when you take nitrobenzene. Now keep star mark for this. When two NO2 groups are in the meta position, when two NO2 groups are present in the meta position, sulfide ions containing salts or compounds, sulfide ion, Na2S, dissociate this. How Na2S dissociates? 2Na plus and S minus 2, sulfide ion containing compounds. You can use this also. NaHS, Na2S or NaHS. How it will dissociate? Na plus H plus S minus 2, sulfide ion containing compounds. Two NO2 groups will undergo reduction. Very important. This is JEE mains question actually. G means question. You learn as it easily for only meta substituted, meta di substituted. Clear? Don't ask for other substitutions, only for meta. Specifically, don't think when we take what happens in the other, don't take it. Clear? Who discovered the given only meta? Okay, but reagent is important. Sodium sulfide, sulfide ions containing compounds. Sodium sulfide is very easy to remember. Online students, are you getting all of you? Online students. From which compounds we prepared? Nitro compounds. Nitro compounds. Next keep getting from cyanides. From cyanides. Primary. Every time we are preparing primary only. Wait for secondary amine. Secondary amine preparation method. Cyanides upon treated with the lithium aluminum hydride, powerful reducing agent, lithium aluminum hydride, or H2 nickel under high temperatures. CH2, NH2. Shortcut mechanism. This is not original mechanism. Just to write the product in the easiest way, you can remember like this. What is lithium aluminum hydride? It is a reducing agent. H. This is not original mechanism, but based on mechanism questions never come. So follow the shortcut mechanism. RCH2 NH2 over. Cyanide can be written as C triple bond N Cn. Hydrogen ion. CH2 NH2. Same conversions already given to you, no? Cyanide preparation. Same conversions we can follow. Aishwarya Bhakti Ariba. Next keep reading from amides. Amides I already given now at the beginning. Lithium aluminum hydride amide. Next from isocyanides. From isocyanides. What is isocyanides formula? RNC. Generally we write like this one, RNC. Same reagent, powerful reducing agent, lithium aluminum hydride. Now we will get a secondary amine. Highlight this, keep star mark. First term we are getting secondary amine. Secondary amines can be prepared. Secondary amines can be prepared. Yes, yes, yes. Only secondary. This is like a shortcut mechanism only, not original mechanism. Okay. Nitrogen valence is maximum 3. See, I'll tell you why I'm adding only one hydrogen to this nitrogen. Left hand side one group is there, right hand side one carbon is there. Already nitrogen is connected by 1, 2. So you have to attach only one hydrogen. That's why attached one hydrogen, remaining 3. Why? To this carbon left hand side one atom only there, nitrogen, but carbon valence is 4, so remaining 3. Clear? Shortcut only, and again logic, shortcut with logic. Some students will get doubt why we are attaching only one hydrogen to nitrogen, because this nitrogen is connected to R left side and carbon right side, 2 atoms over already, so only one hydrogen, because total valence is 3 only. Clear? Right. RNHCH3. Okay. This is not original mechanism, but this is only the way to write the product. Let us do one conversion. How to get isocyanate from alkyl halide? AgCN. Write one conversion type question. CH3CH2. I'll take like this, just a second. CH3CH3 Cl2 H nu A when treated with the AgCN will get B when treated with the lithium aluminum iodide will get C. Conversions. Halogenation of alkenes. Hydrogen will be replaced and halogen will be attached. CH3CH3 Cl2 H nu CH3CH2 Cl. One hydrogen will be removed and halogen will attach. Hydrogen will come out. Right. With AgCN, what we will get? Isocyanate. Correct only, no? NC. Isocyanate. Isocyanate when treated with the lithium aluminum hydride will get a secondary amine. CH3, CH2, NHCH3. This is secondary amine. NC will convert it to NHCH3. Okay. From oximes, next keep heading. From oximes, preparation from oximes. Have you completed this, all of you? Oximes formula R C double bond N OH. Oximes. Lithium aluminum hydride. This is also a concerted type. Mechanisms are there but very difficult to learn. Just you write directly R CH2NH2. R CH2NH2. This part will convert it to CH2NH2. C double bond N part is there na, converted to CH2NH2. This is oxime. If carbon double bond N OH is present, that is called as oxime. Oxime. This is oxime. Example CH3C. Write H also here. I didn't write H. Lithium aluminum hydride. This part will convert it to CH2NH2. CH3 CH2NH2 primary. Oxime, carbon double bond NOH is called as oxime. Oximes. Not CH2NH2. The compounds in which this unit is present are called as oximes. Carbon double bond NOH unit is present are called oximes, not CH2NH2. What I said you didn't get. I think you were writing at that time. What I said, convert this part to CH2NH2. Okay. How to remember? How to write the product? This part is there, no? CH double bond N part. You convert that part into CH2NH2. Okay. From last method, from alkyl halides. Guess which amine can be produced by this method? Primary or secondary or tertiary or quaternary? Which amine? Primary? Both. Both are produced. Both are produced. Alkyl halide, when treated with ammonia, we will get guess primary amine plus secondary amine plus tertiary amine plus quaternary ammonium salts. Mixture of amines are produced when alkyl halides treated with the ammonia. Half of the answer is correct. Okay. Primary, secondary, tertiary and quaternary ammonium salts. Let us see how we will get all this. Okay. First of all, note down that. మీనాక్షి భక్తి మీరు వీడియో వాచ్ చేయండి, అది 2 మెథడ్స్ ఉంటాయి. ఓకేనా, ఈజీగానే ఉంటుంది, ప్రాబ్లం ఏమి ఉండదు. ఐశ్వర్య ఉన్నావా? ఐశ్వర్య ఓకే. లేదు కానీ యాక్చువల్గా మనం బేసిక్ నేచర్, నామిన్క్లేచర్ ఇమీడియట్గా చూడాలి. అండ్ వన్ మోర్ పాయింట్, బేసిక్ నేచర్ ఈజ్ ఇంపార్టెంట్ ఫర్ నీట్ ఫైనల్. సో by given priority for the basic nature, you no need to read for your exam. Clear? But the procedure is, after nomenclature immediately we should cover the basic nature, because basic nature question sometimes depends on the nomenclature. That's why I covered. You no need to read, but for final exam that are important, basic nature questions. Okay, let us see how we will get different types of amines, mixture of amines, primary, secondary, tertiary, and quaternary ammonium salts. Let us take one example. CH3Cl, ammonia. First tell me the products. What are the products? CH3NH2 plus CH3 taken twice NH plus N plus yes, N positive, Cl negative. Correct. Quaternary ammonium salts. Generally, you no need to learn the mechanism also. We will get question in which of the following all types of amines are formed, produced, like that. But for understanding or to remember, we can discuss the mechanism. Mechanism also very easy. See the mechanism. CH3Cl. How can we write ammonia? HNH2. Guess what will be removed? What will be going to remove? HCl. And remaining CH3NH2. CH3NH2. Let us consider this as a step 1 to understand easily. In step 1, you are getting which amine? Primary amine. Now, the formed primary amine react with the alkyl halide, 1 mole of alkyl halide. NH3 or NH2 or NH will continuously react with alkyl halides. First you took alkyl halide, that is reacting with ammonia. You got amine. The formed amine react with another alkyl halide. See second step. I am taking this as it is. This is common. Instead of ammonia, you will take amine. How to write this amine? NHCH3. Okay, now remove HCl. What you will get? CH3NHCH3. This is secondary. Again, this secondary amine reacts with another alkyl halide. Take this as it is. This is common. CH3Cl is common. Now write this. CH3. Again remove HCl minus HCl. CH3N CH3 3 degree. Again this 3 degree reacts with the methyl chloride, but now hydrogen is not there and this nitrogen to remove. Yes, lone pair of electrons. This is completed in your college, Meenakshi. Yeah, okay, but you are answering correctly. Good. See, now we do not have hydrogen to remove. What will happen? This nitrogen lone pair attacks positively charged methyl, because this will get a positive, because that is connected to negative atom, electronegative atom. So to form NCH3 taken 4 times positive, Cl negative, quaternary ammonium salt. So mixture of amines are produced.